Now better?
Yes.
Okay, good. Then again, thanks Ehud for the introduction. Welcome to today's webinar about AIVs, technologies, possibilities and solutions. First of all, please accept my apologies if something goes not as expected or wrong. To be honest, I'm normally used to make presentations face to face, so it's my first webinar, but I will do my best. Okay, good. So let's start. So first of all, a short agenda. What this webinar is about. First of all, a small introduction to myself and the company CTS for which I'm working. And after that, we will go a little bit into history about automated guided vehicles versus this new technology, autonomous intelligent vehicles. And after that, we will step a little bit deeper into the AAV topic with the different types which are currently available out of the box, also possible transfer station or buffers or warehouses which are suitable to work with them, and of course how this all gets integrated via software into the current production sites. And we finalize the webinar with a best practice example, and for sure we will have at the end of the session enough time for questions and answers. And of course, if you have any questions in between, I think Ehud already explained, then you have this raising hand functionality, and of course then I will answer the question as best as possible. Yeah, short introduction of myself. My name is Alfred Paamer. I am the head of factory automation at CTS, and I am focused on new technologies like the AAVs, software connectivity, storage systems. So these are my main focus points. And CTS, the company itself, established in 2006. And we are an international system integrator in the process and factory automation. And we are an owner-managed company with roughly 350 employees. We spread it into 12 locations worldwide, and we have roughly 100 direct customers and make roughly 600 projects per year, and with a total turnover of roughly 72 million in 2019. So here you see a little bit how we are spread it. So our main bases and local offices are spread in Central and Eastern Europe, and especially on the AAV sector, we have already established a worldwide net of sales and service partners, and we are very proud that also with Multipark we have now the ability to provide solutions also in Israel. So CTS is focused on 4 business units, where the biggest ones, roughly 90% of the business, is the process and factory automation. Power engineering and advanced solution is a smaller part, where power engineering is dedicated to power plants, and advanced solutions mainly to big data and big data analysis. The big business units, process automation, is where we are in the oil and gas business, and also in the pharmaceutical and life science business. And factory automation is then more for the manufacturing business, automotive electronics, as well as food and beverage and that things. Yeah, of course, when the company started in 2006, the technology of the AAVs, which is basically the topic of this webinar, was not really existing. And so our background is mainly robotics. And of course, we still do that. So what we provide is basically a robotics business all from one hand. So we have all the engineering capabilities in-house, starting from the consulting and design phase, mechanical engineering, hardware engineering as well as software engineering, starting from PLC programming up to higher level programming for interfacing various third level systems like MES or ERP systems. And also the safety department is in our house, so all the risk analysis, CE processes and so on are done in-house. And as you see on the pictures, we are not dedicated or contracted to one manufacturer, but use different ones. And of course, one of the reasons is this, as a system integrator, we are of course listening and dedicated to our customers. And if somebody has a, let's say, a manufacturing hall full of ABB robots, then of course we will use an ABB robot and not try to use another brand. Okay, good. Then let's start into the topic of the webinar. The AIVs or AMRs, there are very different synonyms for all that stuff. But to make it a little bit clear, so AIV stands for Autonomous Intelligent Vehicle, and AMR stands for Autonomous Mobile Robot. But basically, it's absolutely the same. So, but start a little bit with the past. So the AGV, the Automated Guided Vehicle, is something, it's a very robust technology, already decades in use. The thing is that, of course, the AGVs you see in various factories, or maybe you have it in your own. As I said, they work basically good. It's a robust technology with a not too complex software. But as the name already states, the vehicles are guided. So it is not only the physical guidance, so that you maybe have really a rail on the floor, or you have a magnetic tape, or just a strip where the vehicle dedicates brighter and non-brighter things to navigate, or more modern ones have a laser on top, and on certain places in the factory you have reflectors, so it orientates itself by the reflected laser from the different installed reflectors in the factory. This is the physical thing, but also from the software point of view, the routes the vehicles take are programmed. So the thing is, as you can see on the videos, you mainly have really in these softwares, you place in your lines, and you make your rules, traffic rules, and so on. But the thing is that it is not very flexible. Of course, the use of these vehicles still makes in certain things very much sense. That is out of the question. But especially when you think about the in-production area, where the flexibility, because of let's say flexible production, also high variance, low volume, and so on, all these more demanding things in the manufacturing business is hardly to reach with sorry, with this kind of vehicles, because every change in the infrastructure also causes a lot of work in the system, on both sides, on the physical side and also on the software side. So in 2015, therefore the manufacturer Adapt introduced the first AIV system in Europe, and only 2 months after that, we as CTS already bought the first one and started working with it, and installed also our first fleet in this year. But what is the big difference now? So as you can see also on the videos, especially the upper tools, you also see a complete another possibility of configuration. So these AIVs are in difference to the HEVs not guided. So that means the software inside the vehicles is much more complex and much more intelligent. So of course, there is still a central unit, a fleet manager, which does the coordination of charging and also has the task that these vehicles do not collide. But the navigation itself is purely done by the vehicle itself. So this also works if there is no connection to a fleet management unit, in example. And when you take a look into these configuration videos, then you see that the configuration itself, it is really very intuitive and quite easy to do. So on the right-hand side, this is really the configuration where the user puts in traffic rules like, in example, one-ways or forbidden areas or doors, and also speed sectors. You can make sectors of slower speed, of higher speed. So you have various possibilities to configure such traffic rules in a very easy way. And as you can see, it looks like a layout of a factory. And in fact, it is a layout of a factory. And the thing is, to make such a layout of a factory, it only takes you maybe 15 or 20 minutes, depends on how fast you are able to walk. Because the thing is that these vehicles make these maps by their own. So in the beginning, you really guide the vehicle with a joystick through the environment, and it creates itself this map. And this map is then edited with traffic rules and so on. And on the left side of the video, you see the live view of it. So this red dot, which is moving, is a robot, and the blue line in front of it is the route it calculates online. So that means there are no fixed routes. You just say the AIV, go to there or go to there, or even give him a whole route. So with various stations, he should sequentially go. And it always calculates the fastest route to its goal. And of course, checks the traffic rules by its calculation. So that also means that the vehicle is moving around obstacles. So as the route is continuously calculated, if the vehicle sees an obstacle with its laser, it automatically corrects and adjusts its route to move directly around the obstacle. And this is one of the very big difference also to the HEVs. So if there is something in the way, it doesn't mean that the system has to stop and wait for the obstacle to move away. It really moves around the obstacle by itself. Of course, if the physical environment suits to it, because if there is only then a narrow gap of 20 millimeters, of course, it cannot go through. But basically, there are no fixed lines to follow, which means that if a line is blocked, the system will not stop. It will just move around the obstacle. And it is even that intelligent that the vehicle is able to calculate also a new route. So this basically means when you imagine you have 3 floors to your goal where it should go, it will for sure take the aisle which leads which is the fastest way to the goal. But if this is blocked, the AAV would turn around and automatically recalculate to go through another aisle to the goal. So all this makes clear that, of course, the software is more complex and more intelligent, but due to the really good HMIs, it is quite easy to handle. Of course, also this systems has its limitations. So the navigation is purely based on the natural environment. So no strips, no rails, no reflectors, and so on. But of course, you have to imagine that the algorithm inside the AAVs, it is continuously calculating, and it knows how the environment should look like, and knows through its laser how the environment looks currently. So due to this calculation of the what it sees and what it should see, it locates itself and navigates. So if you imagine you would completely change your environment, let's imagine you have, I don't know, 20 injection molding units, and from one day to another, you move it all away for whatever reason, then for sure, this is a very, very big change in the environment. And the algorithm inside the AAV would have troubles. So this is what I mean with the text here, highly dynamic environments. A very classical example is when you have a warehouse with a lot of pallets and a high frequency of moving the pallets, then such a system might not be the right one because due to this highly moving goods inside the environment is simply too dynamic and would cause us troubles. Of course, there are additional devices which can be mounted on the AAVs to let's say move the eye in a height where the environment is not so dynamic anymore. So basically, that would mean, an example in this pellet storage, that it would look above the pellets. But nevertheless, it means that you need additional devices and additional installations. And in fact, this all have to be considered when making a decision to use such a system or not. And the second thing is, I also often got the question for a rigid, let's say, a concatenation of stations. So in example, if you have one straight line, or more or less normally this either a U-shape or a rondelle, and you have to move from a fixed point A to point B to point C and so on, then for sure such an intelligent system is not the right one for it, because it doesn't follow strictly lines. It really just calculates where to go next. So if there is something in the way, it would try to go around instead of waiting. So it really has to be considered, is it the right application? So a short overview of what we have established so far. So currently we have roughly 165 units now in the field, everything really in production. So no demo systems, but really units which work in productions. The biggest fleet we currently operating are 30 AAVs, and the second biggest one are 20 AAVs, and the average is between 4 and 8. And also from our history, so our main focus, or our main customers are in the automotive and automotive electronics business. So please excuse that maybe the examples are very much on this side of the industries, but nevertheless, I'm pretty sure that from the let's say basic operations and what you see, there are very much similarities which can also be used in other industries. So on the left side, yeah, all the sample of out of the box units and how many are already installed. On the very right side, transfer stations and buffer warehouses. which are used for intermediate buffering, either small or big. And in the middle, a central point, smart factory integration. Basically, this is our middleware, which we developed to easily integrate the AAV system into the factories, and also connect not only the machines and the AAVs, but also third level systems like MES and ERP systems together to get a very easy integration and a good connection to the system. So if we go to the out of the box types, so one main thing we do is transporting boxes, mainly KLT boxes of various sizes. 600 to 400 is let's say a very classic a classic box which is heavily used. And so with the type RG of the AAVs is very dedicated to the transport of these KLT boxes. So either with a front loader like you saw in the left upper video, but also available as a side loader. So basically with a parallel approach to the machine, and with loading or drop off and pickup of the boxes from the left or the right side. So basically same technology, but in different variants. And this is available for smaller boxes with payloads up to 50 kilograms. But we also offer vehicles with a higher payload. So basically for one of the standard sizes is 800 to 600 boxes, but it can also be bigger. It is mainly dedicated for weights between 80 and 120 kilograms. So clearly dependent on the goods you have to transport. What is important to know here is that you also see on the video that the boxes, they are loaded and unloaded either from the front, so with the front loader, and or from the side with the side loader, where the side loader has the advantage it can load and unload from the left and from the right side, so independent from which side it approaches the machine. It is also possible to transport not only one box per AAV, but you can also, in example, move two smaller boxes. So in the smaller, with the vehicles with the smaller payload, it is normally with boxes 400 to 300, but two pieces. This can also be done also on the side loader, where you see this model with this two segments on the conveyor top. And the same thing is also for the types with bigger payload. So in example, you can also transport, instead of one 800 to 600 box, you can also transport two boxes of 600 to 400 in example. On the right side, you see our lifting type. So this one is mainly designed for interconnecting machines with different transfer heights. So we face this especially in brownfield plants, where there are several generations of machines, and the working height or the transfer heights are not standardized. So that you have older machines which have maybe different transfer heights than newer machines, and instead of having separated lifting devices on the different machines, this lift AAV can be used either with low payload up to 40 kilograms. This has the ability to automatically adjust itself between 500 and 1000 millimeter transfer height in standard. And the medium payload type can lift up to 80 kilograms with transfer heights between 650 and 1000 millimeters. So these types are obviously a little bit more complex, more technology in it, but they are very good to do this interconnection between different generations of machines, or to connect to multi-level shelves. This is also an often a use case, so that even if the transfer heights on the machines are the same, but from multiple machines you get the goods, and then on multi-level shelves they are splitted into 2 or 3 levels in the shelf, where the AAV drops off the boxes, an example. Then yeah, especially from the electronics industries, we do a lot of transporting PCB magazines. So these cassettes you also see on the video, so the PCBs are there inside, and they are moved between the different production lines, where the different production steps are done. And they look a little bit different. The main or very obvious thing is this cage you see, and this cage is mainly here for preventing such a cassette to tilt. So it's only for safety reasons. And what is also interesting and currently seen in the video, this type is able to load and unload, so drop off and pick off goods from both sides, so from the front and the back. Why is this the case? The main thing behind this is that a PCB has a direction. So if you transport it from one line to the other, you have to make sure that the direction of the PCB stays the same. Of course, this is here special for electronics industries, but nevertheless, this can also be used if the direction, in example, of a tray or a box where maybe a tray is in it, is very important, so that if you grab it from one machine and you bring it to another machine, that the direction of the goods are stayed the same. So there also this technology of front and back loading would be used. Again, available for medium and low payload. So then, of course, we also have multi-level types. So multi-level types are mainly used for doing 2 steps at once. Like you see also on the video, a very, very typical use case is when we transport goods from the warehouse to the lines. Basically the materials which are needed either at the line or the machine for production. So the commissioning is done in the warehouse, either by an automatic system or very often still by an operator. And then the boxes are picked up by the AAVs. So on the lower level, it gets the full material, and on the upper level, it automatically brings back empty boxes. So you have the pickup of full goods and a drop off of empty KLTs back to the warehouse in one step. And this is on the with the low payload AAV on the left side. It is done with a pure mechanical second level. So as you can see, it swivels either for drop off or pickup, and only used for empty boxes. And on the right side, especially also with the higher payload, so with the medium payload AAV, it is also possible to transport 2 full boxes also on 2 levels. So there are, especially if you have either higher boxes with higher payloads, or you have to transport more boxes and already have it on multi-levels, you can grab it at once with this type of AAVs. And so the last one is mainly, let's say, this kind of a semi-automatic, because this one is normally used when there is for sure still the need to use or to have an operator on the line. It is basically a kind of a pulling trolley transporter. So you see it in the video. It moves this let's say these racks on rolls. So what we use it mainly for is if we have production lines which have, let's say, a lot of different materials and not the ability to feed the materials automatically, but they get commissioned in the warehouse. So an operator puts on such a multi-level shelf trolley, puts the goods, and then one of the AAVs is going there, goes underneath this trolley, clamps it, and then it pushes it through the production area unto its end goal, and there it just unclamps it, and so the operator on the line can use it. And of course, the empty ones it would take back. This is again available then in two different payloads. So with for the low payload with roughly 130 kilograms payload, but including the trolley, and up to 250 with the medium one. So you see, it is a little bit different as there is no direct automatic connection to any machine or transfer station, but has the ability to transport even more payload. For all the more automatic types, there are already a lot of options available, starting with the ability to have not rollers on top, but a belt or coated rollers. So we mainly use it where we have to transport material which is maybe in trays or in boxes which don't have, let's say, enough grip. So the thing is, you have to imagine with the rollers, when you have materials to transport which have, let's say, not enough grip, then the rollers would spin. And to prevent this, we use then a belt in this case to avoid these problems. And the same is if you have, an example, carriers. So we often face this when we have to transport metal carriers, where they only have normally 4 points where they have contact to the surface. So it is impossible to transport this with rollers because it will fall down between the rollers. So in that case, we always use a belt. And as all the types you saw, these are really out of the box types, but of course they are kind of standardized for a certain size of material, a box or whatever to transport. But nevertheless, of course, we are still able to change that to our customers' needs. So also for that, we have extension options in width, length, and height. So we can customize the height, the width, and the length. We also have an option for an automatic width adjustment. So basically that's used when you have boxes with different sizes and want to transport it all with one type of AAV. So the side guide rails are then automatically moving in the correct position. And these options are available for nearly all types. And one last one on the right side, we are also in the hospital business. We try to do more and more. So this is called the Medilog. So it is basically an AAV which has the shelf on top, which is closed. So it is with a lock, has an synchronized database on it. So it synchronizes with the hospital database, and with an RFID chip, you can lock and unlock it. So basically it is used for transporting drugs from A to B inside the inside the hospital. As I said, that our main business is in the automotive and automotive electronics. Nevertheless, I also have to admit that we have customers also in the metal processing industry and also in the medical product industry. So an example, we also have a customer that make dental products, and they basically use the AAVs in their production quite similar to the ones in the automotive industry, but the products are different. And that's also why I said in the beginning that I see very much similarities to other industries, because let's say the basic problem or issue, or let's say the main purpose of these things is to interconnect the warehouses with different machines and machines with machines, and this basic setup is in a lot of industries and a lot of factories. Here's a small comparison between the low and medium payloads devices, and the main thing is these devices can be used in hybrid fleets. So if you have small AAVs, you can mix it with medium AAVs, all with the same software, same fleet management. So there is no difference in look and feel and so on. So you can completely mix it. And the main thing to be aware of is that the medium payload AAVs, they are simply bigger, and bigger means they need more space. But all other things are really basically the same. So HMI, look and feel, and so on, is everything is the same.
Mr. Paamer?
Yeah.
I would like to stop because there is a question.
Yes.
With which kind of what is the benefit or the upside of your robots on top of the competitors in this field?
So based on the competitors in the field of AAVs, we have several advantages. The first thing is we have now, with 5 years of real production environment experience, we have a lot of experience and understanding of our customers, and that's also the reason for all these out-of-the-box types we can provide. So this also means that also our delivery time is quite fast in comparison to others. And what is also a very main point is that the basic AAV tape we use, it is the one which is on the technology side. It is the most experienced and the most grown up. So that's also we as an independent system integrator, we always evaluate several different manufacturer types of base platforms on the market, and we still clearly see that the LD platform we use as a base is still the most grown up and the most reliable. That's also the reason why we use it, because we have no doubt we can sleep well when we know there is a 24/7 production at customer sites, and our AAVs are doing their work there, and this works good. They are reliable, and we also see from our internal benchmark tests that the competitors, especially with different base platforms, are struggling a lot with that. And one other very big advantage is that we already have developed a software platform, a middleware, which makes it possible to very quickly connect to not only the AAVs, but also connect the different machines, PLCs, robots, and also with our open interface, we can establish connections to MES and ERP systems really fast.
We have another question. Is there a robot for a 500 kilo payload? What is the position and accuracy replicability?
Mhm. So currently we do not offer an AAV with such a high payload. It is one in development. It was planned to be released by the end of this year, but due to this Corona thing, it will be a little bit delayed. I expect Q1 or Q2 in 2021. But this is then really for high payload, so up to 1.5 tons. And the accuracy, so the accuracy in the natural is always dependent of the natural environment, but for the accuracy on the pickup and drop-off points, we use triangles which are installed on this point. So you can imagine that really as a metal triangle, and this is kind of a separate location point for the robot. So that means it searches for this triangle and then positions itself according to it. And there we have an accuracy over the whole fleet of 20 to 30 millimeters. And if there is even a more higher accuracy needed, we have the ability to switch over to a high accuracy positioning system. So that's the name of it, which basically is the ability to use a 100 centimeter long magnetic tape, which is automatically founded, and then so it follows then the last meter. With that, we have an accuracy of plus minus 10 millimeters, and you can mix this up in the whole factory. So everywhere where the triangle is suitable, you can use the triangle, and you still have the ability with the other system to achieve more accuracy and or also very position in very narrow areas where the robot would not have enough space to align itself on the triangle.
So the new development is for half a ton, 500 kilo, or 5 tons?
No, 1.5 tons, so 1,500 kilograms.
Okay, thank you. Another question: does the robot can fit in a clean room environment, class 4?
The robot itself is in standard class 5, but we already have it also in class 4 running. And the thing is, what we have done is we have installed everything, and the height of the robot itself. So we are always under the product. We never reach the height of the product. And what we have done was then an acceptance test directly at customer side. So the customer itself measured the particles and approved us to work in the environment. But there is no standard certificate which says ISO class 4, but it is definitely possible.
There is another question, and then we will continue. Hello, Alfred, do you hear me?
Yeah,
Okay,
now I hear you.
There is another question, and then we will move forward.
Yeah.
Is there a robot to transport pallets weighing up to 200 kilo?
So the robot for the pallets will be the 1.5 ton version. It is with the medium payload. It is possible to put on with the width and length option the conveyor that a pallet fits on it. But the thing is that the payload is then only roughly 100 to 120 kilograms, because the structure itself is more stable and let's say needs too much payload by itself. So unfortunately, no 200 kilogram pallet currently not possible. Should we go on?
One more question.
What is the work conditions the robot needs for traveling inside the factory? Also, if they have dust or other things, and what about maintenance?
Okay, so basically, in the specification it needs a floor according to regulation AFF12. What does that mean in real life? So we basically on a standard concrete floor, where when you have small bumps in it, the AAV still works. But of course, the more bumps you have, the more let's say yes, struggling with the wheels and so on. But nevertheless, so a basic concrete floor is suitable. Also, if there is dust in the air, the thing is, there is no let's say fixed value where we say, okay, with this amount of particles it will not work anymore. In fact, the thing is, it works also in dust environments. The thing is, you have to be more accurate with cleaning. Why? Because you have to imagine the eye of the robot is the laser. So if the laser is full of dust, it will not be able to move anymore, because it sees virtual obstacles. So basically, it sees a wall where there is no wall, and then it will not move. But if there is enough or a higher cleaning interval, then it is still possible to also use it in a dusty environment. And regarding maintenance, of course, according to the standard specification, of course, clean floors, low dust, and so on. The maintenance is very low, so mainly cleaning tasks and visual control tasks. So you have to control if the lasers are clean and free, and also if the rollers are still working correctly regardless of the dust. And the main maintenance thing is that all of the AAVs, they have 2 drive wheels and 4 caster wheels. And so the drive wheels, of course, also the rubber is a wear part, but the rubber of the driving wheels, from our experience, it works between 1 and 2 years. But with the caster wheels, it depends also on the use. We have customers, they change it every 6 months. We have customers, they change it every 1.5 years. So this is dependent on the environment, of course, you use it, and how heavily you use it. But the maintenance of this caster wheels itself, very easy. So this is just, I think, 4 screws, and then you put on the new wheel. And the thing is that this can be done by the end user itself. So these are the main maintenance works.
Okay, we thank you, and let's continue on.
Okay, good. So yeah, as I said, the transfer stations, either in warehouse or inside the production, to have let's say, yeah, this intermediate buffer. They can also be placed directly in front of a machine. There is maybe already a conveyor. So these are things which can be used, but they can either be supplied by the customer itself, or it's also possible that they are not needed anyway. And what we have developed, especially for the electronics business, but maybe it is also suitable for other ones, is an intermediate buffer system. This buffer system is the main purpose is to store these PCB magazines with the PCBs. It has input-output ports. So you see also on the picture there are the AAVs. So they automatically bring the PCB magazines and also get the PCB magazines from the buffer. And this buffer is not designed for storage of days or weeks. It is really an intermediate buffer, so that you have the capability of having the goods which are, let's say, cannot be used by the next step because of normal and standard asynchronicities between process steps. They are put in here and then automatically put out to the next process steps if possible. And especially in the electronics industry, we see the very, very big advantage that in the production or on shop floors, every time I go to the factories, the shop floors are full of KLT boxes and PCB magazines, which are stored there by the operator before it can go to the next step. And with such buffer systems, you gain a lot of more production space. So that's the main reason for such a product. Yeah, then let's go to the very, very important connection part. This is the software. So what we've done since the beginning, we have developed a software which is basically designed to be independent of the base platform. It is an module-based toolkit. So each module is kind of a tool which has then a standardized interface, and all the tools are communicating together over the standardized interfaces. We use their open connectivity REST interfaces, so a very modern technology, easily to use with web services. Also, all modern production systems, MES and ERP systems can be easily connected through this connectivity interface. And beside the thing that, of course, all the AAVs are connected and we communicate to them, you see all the interfaces around the circle. This basically means that we connect to all the production equipment to get the needed information to create these transport orders for the AAVs, either automatically by the software itself, or to provide this information to upper level systems that they can use it to then create, based on this information, these transport jobs for the AAV system. And all the HMI we've developed is web-based. So this was one of the main goals that was always important for us, that we are able to use the interface from all devices, regardless if it is a tablet on Android or iOS based, or if it is a PC or whatever. If you have a device which can host the web browser, you are able to use the software. And we have provided the ability of a kind of a live demo. So I will switch over to my web browser. And what you see here is I am now online at our office. So we have provided a server with some simulation data, which is available through the internet. This is only for our simulation purposes. I have to say that all, so on many customer sites, of course, the software is installed. It is, of course, not available through the internet. So it is in their own production environment and secured. So we've done this separately only for demonstration purposes. So an example, what we see here is a list of transport jobs with different status. So which AAV is handling the job. It is currently on the road. This one is already dedicated to an AAV, but has not started. This one is an example, is in the queue, but not dedicated to an AAV, and so on. So a very basic overview of all the jobs which are active. Of course, there is a dashboard functionality where you are able to see at a glance the status of the fleet of the different vehicles and which status they are. Are they working? Are they available? Are they in an error? Or are they charging offline or whatever? And also with daily KPIs. So also, yeah, what was the percentage of the jobs it done from successful to unsuccessful and so on, how many kilometers it went, how often it was charged, what is the battery level, and so on and so on. So basically a quick overview about the status of the fleet together with daily KPIs. And of course, there are also histories inside for the orders, for the alarms. So basically, all the data is available. And to have this also in a kind of statistic, we provide also a reporting module. So with the reporting module, it is possible, in example, to have a report about, in this example, the top 10 alarms. Then you can also group this to the different robots. And of course, this is mainly to have the ability for better also searching for errors. So with the statistics, it is also an helping tool for the maintenance to see, oh, okay, where I have more problems. Is there maybe a specific device or a specific station or whatever which causes more problems than other ones? And this, of course, also there are abilities to see, okay, how many transports per day. Okay, now this is you see I've chosen 4 months, so this is too much for the to have it in one day, but okay, when you have it for per week, in example, or you have it then per month, then of course it makes much more sense, and it gives you an overview about the performance of all your AAVs based on the time frame you're choosing. Also, there are statistics available for charging times, down times, up times, and the thing is, everything so all the base data used for these statistics are of course available for you. You can either print it, put it into a PDF document, or just export it into Excel. So you can also use the data then to put it into reports with your corporate identity or whatever. So basically all the data you need is or you see is also available and easily to export. And then there are things like door and elevator controls, so where you can also configure the doors you have, the elevators. You can configure which AAV is allowed to move through this door, how many are allowed to move, in example, inside a lock at once, or does all the other ones have to wait until the one which is in is already gone, and so on. So a lot of possibilities and options to configure your own small logic which fits into the production. And besides that, there is a very cool tool. It is called the Universal Map, which is basically used to have a live view of the environment and the layout of the factory. and it takes its time. Slow internet connection. But yeah, nevertheless, you will see soon that no, it is basically a little bit like Google Maps. So we tried also that from the usability that it is very, let's say, easy and intuitive. And of course, you see here all the AAVs moving. Also, when you go on it, you can see the current status of it. But it is not only the AAVs which can be shown here. You see an example here, our tower version, the transfer stations. This is an SMT, so a production line inside an electronic factory. And the thing is, all machines which are connected to our software can be shown live in here. So you can also show the status of the different machines. Are they available, non-available? Do they need something? So do they need material, or do they have material to be moved away? And there is also an open interface to accept data from other devices. So in example, if we have a forklift or a Kanban train, and you have a tracking device on it, when you send us the tracking data and even a status to it, then you can see this also moving live inside this map. So it is not only dedicated to the AAVs itself. It can also show any other data which is put through the interface. So you see the software. It is very intuitive, very modern, and it's one of the key points to connect all the different machines and systems inside the factory together to get the optimum out of the AAV system. Okay, so let's move back. Good. So last topic, best practice. Again, because we do so much in the electronic production, please excuse that it is an example of that. But I'm pretty sure that there are you will see similarities also to your production. So the typical processes there are the commissioning of the materials from the warehouse to the production and testing lines. So basically that means that in the warehouse, the operators are preparing their material in different boxes, trays, or whatever. Sometimes this is even done by robots, but to be honest, the main part doing by hand. So then the distribution of all this material is then normally done via a train. So in a Kanban system. So then of course you need, first of all, more space on the production line, because the Kanban comes in a fixed time frame normally. So it puts there a lot of material which holds until the next time slot is reached. Or what is even worse, and we see very often, is that the operator on the machine or the production line goes by himself to the warehouse and grabs material. And of course, the feeding of the material is then also done manually. So what we here again, it is in a typical environment of electronic production. You have testing stations, you have your SMT lines, and you have a warehouse, the Kanban drivers, and always some Kanban shelves at near of the production site where you drop and pick up the material. So what we normally start is to have first at least 2 phases. So the first phase is to start with some dedicated lines, production lines or production machines to move from manual supplement to automatic supplement via the ALVs. So that means that, of course, it is very, very important to understand that it does not make sense to, let's say, move everything at once, because this, we know from experience, will cause huge trouble. So it is very important to do it step by step. And normally, what we start in the electronic production is the supplement of the materials via KLT boxes. So not with these PCB magazines. You see here they are still transported by manual wagons or trains, but the materials for the production lines, they are commissioned here in the warehouse area, then gets automatically picked up by the AAVs and dropped off then in the different locations in all the production area, dependent on where they are needed. So this basically also means also quite a step in the software integration, because of course the lines say, hey, in 10 minutes I need some material. This goes to the warehouse where the commissioning is done, and then with an automatic scan of the commissioned boxes, we ask the ERP system, okay, to which replenishment job is this box dedicated? And then the AAV knows, okay, I get this box and bring it to line 1, 2, 3, or whatever. And after this first phase with these chosen lines, then there is kind of a phase 1B, let's say, where you can, or we normally speed it up to more lines. So we start with a few dedicated lines to get this, you know, this integration of the AAVs into the factory, to also get the operators used to it. And after a pilot phase of a few months, we move into a real, very productive phase, and that's the point where we then step up to integrate more and more lines. And that's a really, really cool thing in this with this system. You start normally with 2, maximum 3 AAVs and with the software, and then you can step up really step by step, either only 1 more AAV or 2 or 3 at once, and really dependent on how many transport you have to accomplish. And after this first phase, many of our customers do the extension of the fleet by themselves. So we only deliver the AAVs, and they mainly integrated also by themselves. So the basic setup is very important, and we put very much focus on it. And after that, a lot of things can be established by the end user itself. And so in the second phase, this is then in the electronic production, it means that also the transport of these PCB magazines have to be fully automated. So that basically means buffers also for this come into place, and the transport of these magazines from and to the buffers or directly between the lines all goes automatically, which implicitly means all machines are now connected to the software, and the software itself is connected to the ERP and MES system. And of course, from the software side, it gets a lot more complex. But due to these open interfaces, we still have the ability to make this integration very seamlessly and very fast. And in this phase, we are able to reduce the manual transports really to a minimum. And also, what is clearly seen is that the areas on the shop floor where you store the operators have stored the material, they get less and less. And of course, with more production floor, you have the ability to maybe use it for some productive machines. And to have this as a summary, the key points of the integration. The first is that even if it is really easy to set up the map and do the configuration of the traffic rules and so on, It is easy and it looks easy, but it is very important to understand that nevertheless, the AAV itself is a partly complex machine. And it is very important, the same when you have an injection molding machine. For sure, you have a technician which has a very much knowledge about the process and the technology. And the same is with the AAVs. Also, there are skilled and trained maintenance employees necessary to get the best out of it. And of course, as I already mentioned on the example of the electronic production, it is really, really important to do it step by step. So start small, get your employees used to it. We've made really good experience if they are from the beginning on are in the same boat. Then we also get often very, very not only positive feedback, but also inputs from them. What could be more optimized? What could be done better? And especially what we faced is that when we give them names, it's always good, because if it seems that it's not so easy to or it's easier to say, this robot is not working, bad robot. But if you give him a name, then normally at least we experience that the people are more more kind to the robot, let's say in that way. And last but not least, of course, the environment has to be suitable, but this is something which is let's say also kind of the pilot phase. And this is the last and the crucial point. The pilot phase has to be declared as a pilot phase. Don't make the mistake to think that, okay, we push start and then we have 100% productivity. I can tell you from experience, if you integrate such a system in this pilot phase, there is also a lot of playing around with the devices. Going in the way and try how it reacts and so on. So it takes its time until everybody is used to it, so that you get really the full ability out of the system. Good. So basically that was the last part. Thank you very much. And of course, if you have any question, please feel free to ask.
Thank you, Mr. Paamer. One question regarding charging time. What is the
charging time?
What is the charging time and the charging procedure? I don't know.
Okay. So charging is.
How long can it run after a full charge?
So basically, charging is done automatically. And normally, we have an uptime of 1 shift, so 8 hours. The thing is that it is really also dependent on, let's say, how all the things are configured and optimized. So in example, we always try to not use always max speed, because then you have a lot of stop and go. Stop and go means that you need more energy, which is not that good for battery. From experience, we see that we normally have an uptime between 8 and 10 hours. So we always say, okay, 8 hours, so you can run it for 1 shift. And then when it has to charge, it charges automatically. We have a range, so normally we don't use it more than or lower than 20 or 25% of the battery, to prevent the battery from getting damaged. And then to be fully loaded again, it takes between 1 and 1.5 hours. In a fleet, the thing is that the fleet manager controls the charge management of all the AAVs. So also if there is some idle time and there is no transport job in the queue, also the fleet manager makes sure that one of the AAVs is going to the charging station. That not all of them are empty at the same time. So this is part of the charging management inside the fleet.
Sure.
Alfred, another question.
Yeah.
With what systems, like software systems, your system can communicate, like SAP, SAP, or Priority, or other factory management?
Yeah. So we have connections to yeah, we have already SAP connections. We have connections also to ERP systems written by the customer itself. Then we have connection to MES systems like ETAC, Chemline, and also a lot of own developed MES systems by our customers. The procedure is basically always the same. The good thing is that all these modern systems, especially on the ERP area with now SAP, HANA, and so on, they all are very used to the REST technology. So it is really easy for them to connect to our system because all of our communication is based on REST. And of course, we have finished interfaces and documents for it, and sample programs. And so the process of connecting to our system is very easy and very fast. That's at least what we experienced so far. I can tell you the fastest MES connection was 12 minutes. I was, to be honest, I was also surprised, but it was really nice. So the customer was with 2 development guys on our side. We had a discussion for 2 hours. We sent them a sample program, and when we were there did the installation and commissioning, so it was really up and running. It was really, really cool.
Another question: will I get a notification that the AIV is blocked and can't move? Does it go back to the transfer station, or just waiting for moving the block?
No, so it works in the way you can basically, first of all, you can configure also that the AIV is, let's say, really talking. So if there is something in the way, you can configure it that it says, hey, move out of the way. Of course, this only works if there is some human being there. If not, it automatically try to move around the obstacle. If that is also not possible, it automatically tries to go another way to its destination. So it would really turn around and try to find another way to the destination. If this is also not possible, then yes, of course, there would be an alarm in our software system that the job takes too long and there is something wrong, and somebody has to take a look into it.
Okay. Do you need light for the robot to work? It can work in dark spaces?
Of course, we don't need light.
What is the minimum speed and the maximum speed?
So the maximum speed is from medium payload 1.2 meters per second and low payload 1.34 meters per second. From experience, I can tell you that normally we don't exceed the maximum speed of 1 meter per second. This is because we made the experience that 1 meter per second is, let's say, the maximum speed of an employee when it's moving. And when the robot is not faster, then it is not taken as a danger. And also another thing is that you have to imagine the robot. Of course, it's always, let's say, he drives on site. So that means the faster it goes, the more he has to see. So if then something goes in the way, it has to stop more, or has to need more energy to break down. So normally we say an in production. So what we normally face that the systems are moving between the lines, also between operators and so on. The average speed is between 0.6 and 0.8 meters per second.
Okay. What is the delivery time for critical parts?
So you mean critical spare parts? We have all critical spare parts on stock. So that basically means it's only the transport way between our warehouse and the end customer.
Okay, Mr. Pאמר, I will switch to Hebrew for a second. יש לכם שאלות נוספות? זה הזמן המתאים לשאול. בעברית, אנגלית. אני אתן דקה לחשוב, ומקסימום אחרי זה נעשה עוד מפגש כזה של שאלות ותשובות, מה שאתם צריכים. Mr. Pאמר?
Yeah.
What is the lifetime of the battery?
5 years. So it is the manufacturer of the battery says 7 years. From experience, we say 5 years.
Okay. Do you have this kind of application in a plastic factory? In injection, extrusion?
Yes. So we have also, I know I was talking a lot about electronics, but there are a lot of customers which have this mixed, especially the automotive branch, which they have their own molding units. So they do the plastic parts by themselves as well as the electronic parts and the assembling. So yes, we have several plants. They have their own molding units, and where we get from the molding units the boxes with the parts and get it to the warehouse.
Can you explain, please, more about maintenance, regular maintenance, and the expertise that the factories needs to have to use this kind of system?
So for the maintenance, it is really quite easy, because the main maintenance is cleaning and visual checks, and maybe adjusting some screws on the spring of the charging unit. And that the main thing is to exchange the main wear parts. These are first of all the caster wheels, and of course after longer lifetime the rubbers of the driving wheels. So that basically is most of the maintenance work. But for operating the system, so for the employees who are really in technical charge of the units, so kind of supervising on technical side, we recommend to have let's say a good understanding of software, because and of course and the main thing is also an interest in robotics. We face an experience that the employees on our customer sites, which are responsible for the systems, they are dedicated to it. They like it, and then it's even easier. But most of them have a software background in kind of and either PLC programming or robot programming or higher level programming. That is, the program itself is not the critical part and is not needed, but it makes it often easier to understand some things. And Also, if there is some, let's say, error solving or problem solving, also together with our engineers, it makes it more easier if there is a software background.
Another question. Does the AIV system work with Wi-Fi or radio frequency?
Wi-Fi. So 2.4 and 5 gigahertz. 5 gigahertz preferred from experience because normally there are more free channels than on the 2.4 gigahertz. And technologies are BGN, so AC is coming, but the thing is that there is not so much traffic over the Wi-Fi, and until now also it works also in full 2.4 gigahertz networks.
אוקיי, אני אחכה עוד דקה למי שיש שאלות, מוזמנים לשאול, ואם לא, נסכם וניפרד. Okay, so Mr. Paamer, I will summarize in a minute, and then we'll say thank you and end this meeting. אז מה שהיום זה היה קורס בסיסי ברובוטים ניידים. אנחנו מאוד מאוד מאמינים בטכנולוגיה הזאת, חושבים שמפעלים, זה סוויץ' בראש לכל המפעלים בכל התעשיות, סוויץ' בראש משמעותי. החשיבה צריכה להיות לפי דעתנו על תהליך. ההחזר השקעה, אפשר לחשוב עליו כמה אנשים אני חוסך. אנחנו רוצים להרחיב את הראש ולחשוב על איך אני משפר את התהליך שלי, איך אני מגן על המלאי שלי, איך אני בונה את התהליך הרבה יותר נכון וטוב והרבה יותר רזה. אנחנו רואים גם בתקופות משוגעות כמו עכשיו וגם בתקופות הרגילות שתהליכים כבדים גורמים להפסדים הרבה יותר משמעותיים מכל הכנסה של אוטומציה, אלא צריך באמת להסתכל על התהליך ואיך שהטכנולוגיה הזאת יכולה לפשט את התהליך ולשפר אותו. אם יש עוד שאלות אתם מוזמנים, בינתיים Mr. Paamer, I would like to thank you to sharing your knowledge and your time, and let's hope that if there is another question, we are here and able to answer, and we would like to thank you.
I also thank you for the opportunity. Hopefully, it was and of course, if there are any additional questions, normally from experience they arise mainly then afterwards. Just summarize it, and I'll be happy to answer everything I can.
Of course. Thank you very much, and תתעדכנו בבקשה בדרך האתר שלנו במפגש נוסף של שאלות ותשובות שיהיה כנראה בשבוע הבא. Thank you, Mr. Paamer. Thank you.
Thank you.
Bye bye.
Have a good day. Bye bye.
Bye bye. Thanks.
Auf Wiedersehen.
Auf Wiedersehen.